Hello, my name is Matt Porter. It is my distinct privilege to be able to present a collaboration with the one and only Dr. Henry Maroc, titled First Do No Harm on Making AI Safe, Secure, and Trustworthy. So really, we consider that generative AI or Gen AI, it's really increasingly being used in medicine and education. Really what we see some of the acute impacts being that with residency selection now that with Thalamus GME adopting AI as part of their screening process for medical students, uh, we have a Bridge AI, which is running NVIDIA models for the purpose of helping clinicians manage documentation. And then we have such tools as Perplexity AI, which is acting as a search engine replacement as well as being implemented already in learning tools in medical schools, like the infamous Anki. Perhaps one of the biggest challenges is that there are over a million plus public AI models and data sets, with most of them being on the open platform Hugging Face. So it begs the question, well, how can individuals and institutions adopt quality AI? Well, we humbly submit that we developed a novel protocol of software tooling to train and host small multimodal models on device with a thoughtful implementation of the Unreal Engine, Open Quantum safe protocols for encryption, and really the open source community as a whole, all being poured into the thoughtful implementation of the alignment of hardware and software through such tools as TensorRT from NVIDIA for optimized AI inference, and PyTorch, which is really a byproduct of the work from the Meta Labs on taking Cafe and the Torch library tooling from the Lua programming language to be able to make machine learning and really we think of as AI accessible to everybody. And so we end up having this implementation of small multimodal models that have capabilities for multi-language conversation understanding as well as audio and text generation. And our goal is to be able to have an answer from inside of medicine as far as what are the possible options for not just using AI, but to understand it. And with that being said, we'll actually show versus just telling. So perhaps one of the first things we'll bring up here. So let's do a little switcheroo. We'll just do this. So one of our first tools developed here is actually fully contained coding suite. And the nice thing about this is that we present not just one model and try to funnel folks into that, but really we think of as a menu. These being some of the major owners. So we have GitHub, which has quite a number of different models. Everything from the Phi that owned by Microsoft to Cohere from Cohere Labs, Meta, as well as Mistral. Then let's see, we have Grok, which is not XAIs, but Grok with a Q. So they are a processing chip company, and so they run these models. Again, noting even some of the newer ones like the DeepSeek models that have been all abluz. Then we got Mistral, because right, they're very big into the open source community. Come on, you. Oh, there we go. OpenAI because, I mean, of course. And really seeing, again, it's not just one particular model or one chat GPT, but it's the embedding models, it's the multimodal models, it's the encoders, decoders, really everything that provides folks to be able to securely look at those APIs and be able to evaluate them for themselves. And of course, as some of our own implementations. And we'll go ahead and then showcase what that looks like. So let's see, what are some considerations for managing diabetes in the elderly? Okay. See if the demo gods are kind to me today. Oh, look at that. So again, what we're seeing here is a small model. So when we say small, it's at a high level. If we think of anything below 10 billion parameters for an AI model, parameters being roughly, think of like neurons in a brain. And so big models like GPT-4 has somewhere akin to like 450 billion parameters. And so we operate at a much smaller scale because not only is it more efficient, uh, it also takes up just less memory. So most of these models are somewhere between 2 gigabytes to 5 to 10 gigabytes. Uh, can easily fit on device, can easily fit multiple on device. And again, while I know many person would have concern on, oh, well, what about the hallucinations? What about, is it obfuscating information? Well, the reality is that any model is going to be as good as the training that it has, and it's about having a menu to evaluate in real time, to be able to asynchronously see what a model can do and run your own individual benchmarks, because each person has a different risk protocol and really a different consideration of what they feel is appropriate. And so we're not here to tell anybody this is how you should end up figuring out how to use a model. We are here merely to provide the menu, and from there, empower folks to make the decision for themselves. And this entire suite is all actually on one of our GitHub pages with a specific plugin that we've made called rose.mvim that allows us to be able to securely get these different APIs as well as the Compass model specifically running on device. So you're getting really the best of both worlds. So number 2, so again, Unreal Engine. So what is it? High level, it is a tool to be able to render environments, render worlds. And so we see this here, this world that we're just looking at, this kind of base. And well, it's a little, doesn't really leave, there's not really a lot there. So let's go and fix that. So we're going to, let's see here. There we go. Map. So let's look at a clinic, but not just a current clinic. Let's look at what suppose we could see what a clinic could be, uh, given a little bit of time. Because I think everybody is thinking about how can we really make these clinics, how can we really bring medicine into the foray? Let's see. And of course, there we go. Okay. And so what we're seeing here, again, because we've made this all editable in this world, is this entire space that we've devised. And not only do we end up having this entire space that can serve as a way to be able to, again, asynchronously interact and simulate different environments, Well, we have ways to be able to make a much more humane UI, specifically with what are called metahumans. So not a person, it's not alive, it's not magic. This is a human avatar that can then be aligned with models that can generate voice, that can generate response, and to be able to have asynchronous training, low stakes, and serve as a way to trial out things in a very safe, non no consequence sort of environment. So the great thing about something like this tooling is that in signing the EULAs that we have with uh, the good folks at Epic Games, everything we use here is free. Uh, they have a model or business model where it's called the first $1 million, which we have pre-revenue right now, but the first $1 million, everything is no royalty, and really we can use this tool as a way to show a menu of different ways to build quality AI. Again, linking it to these environments based off of what a person is looking to do. Okay. And now probably the one that I'm personally most excited about, because it's near and dear to my heart, is, well, what do we do for security? And so what we've done is implemented one of the first uses of the NIST Post Quantum encryption protocols. Now, what does that actually mean? So, again, at a high level, where is it? No, it's not there. There it is. Okay. So, at a high level, every computer in the world, so I'm going to put this right here, when you're connecting to another computer, or when you're connecting to the internet, excuse me. Nope. There it is. So you are a client and you are connecting to a server. Every single website, whether it's PubMed, Google, Yahoo, whatever, your computer is connecting to this serving computer that's serving up some application. Now, this is a secured connection because you are generating what's called a certificate, cert. And it's going through different layers of security, particularly for encryption. Every time you see an HTTPS, that is a secured connection. And so you send this cert, and then the server acknowledges that and sends the request back, making a handshake. And that handshake is secured by typically a public key cryptography scheme. Not scheme as in something nefarious, but scheme as in a agreed upon encryption protocol. Some of the more common ones like RSA, elliptical curve Diffie-Hellman. With the advent of quantum computing, we now have had this big push really over the last 8 years where it's been this, what's the phrase I'm looking for? A international effort to develop new encryption protocols that can stand this new potential onslaught. And so we've developed these on device using the public source, free to use and tool around with OpenSSL and Open Quantum Safe libraries to be able to actually have that security and bring it in with use cases ranging from securing the legacy servers to signing models, documents, data with post-quantum secure encryption protocols to ensure authenticity and really prevent obfuscation or nefarious misrepresentation. So what does it actually look like? Well, it looks like this. So we're implementing compilers, particularly focusing on Ziglang, the implementation of Scache, so Rust-based, and of course, the C library, and being able to have these encryption protocols that are operating at the kernel level, so the core of the processor. And so what it's doing is building all of these different encryption protocols through the liboqs library. And so you'll see that's what all those names are, the Sphinx, Falcon. These are all NIST, so National Institute for the Standards of Technology, endorsed encryption protocols that are either pure quantum or hybrid implementations acting as a go-between while folks are all making the shift to the overall fully post-quantum protocols, mostly from the standpoint because there's just not really a known standard as far as how robust are some of these things as they're going about. And so with this, we also develop these testing suites that ensure that we aren't just getting, we're not just compiling it, but we are validating, we are verifying it. And a lot of this is thanks to the fact, again, that mindful implementation of using GPU amplified processing. So taking the CUDA cores and the implementation of optimized CPU cores, those logic cores, through an Intel-based processor to be able to actually have the compilation occur. Since processors at a first principles level are actually implementing quantum principles. It's the fundamental use of the binary, the 1 and 0, that takes it from the quantum to the more classical physics model. But prior to that delineation of on or off, 1 or 0, it is operating really on that quantum principle. And all quantum really means is just physics that are smaller than the eye can see. Not quite as exciting when you perhaps put it that way, but I think in some ways that should be the point, is that it is not magic, it is math, and particularly math that is near and dear to my heart because having studied some nuclear engineering during my years of undergrad and then looking at the particular nuclear weapon, nuclear reactor problem set within the civic region during my time in the service as an intelligence officer. And so seeing uses for this that actually are acting to defend without bringing more weapons to bear is definitely a very exciting use case for me. So while that is chugging along, go ahead and move to our next piece here. And so we first built a library, and then we're going to build the actual provider. Right, and we've all built all this already ahead of time, but now just showing just that process because it needs to be repeatable. Otherwise, well, it's just sort of not real. And again, so we are validating, not just compiling, we are validating each of these protocols as we are building them out. Because again, it is not just about, look at this, it's, hey, we can replicate it. It is reliable, it is durable, and something that anybody can be able to take the code base and pull it down. The one caveat being that everything that's being compiled right now, everything that's being built out is running on Linux, specifically Arch Linux. And so with that being said, while it is most likely able to be replicated using particularly Macs, if you were to use Windows, you would have to use what's called Windows Subsystem for Linux 2 and ensure that you actually did have the right different packages. It's done intentionally because this is very important technology. And so it's with the mindfulness that we put enough checks and balances into place where we'll just say that it takes a little bit of understanding to be able to actually compile, build this, and as it should, because this is something that this is not something to gain funding from just based off of the product that's made. This is a fundamentally important technology for protecting the most vulnerable population, for ensuring that future communications, future privacy and security is accessible to folks and is stewarded by those who have the mind to be able to actually implement it without unduly trying to move towards a profit centric model for this. And so what it's doing with this is not just in doing the testing, but actually printing out all of the results. So again, we can have things that are repeatable, reproducible. Well, I'm not just waiting for that. I do. Yeah. And so let's see. Yeah. And now the big one. Was it this? 90? Nope, nope. Okay. So again, what this is it's actually building out, what's it called? What's the word I'm looking for? Yeah, get a little bit more flexibility. So it's actually building out all of those different certificates, all of those things in the full suite. And it's not glitching, it's just literally producing that much stuff just all right then and there. It's, yeah, right. Just like, But so, because it's implementing all this into the core of the system to then be able to serve that up. And again, it's all public source information. Nothing had to be taken, and really the credit goes to the great folks who are behind the OpenSSL project and the OQS, the Open Quantum Safe project, for putting these libraries out there into the public so that way they can be used. It's absolutely phenomenal and a great inspiration to be able to learn from the great work that they're doing and really being able to take our small part of the task of being able to make AI that is safe, secure, and trustworthy. So again, just forgot to mention what's it called? That rose.nvim that I was speaking about earlier. Okay. There it is. So it keeps a log of all of the chats that are occurring. And that way, again, it's none of there's no telemetry involved. It is just all on device. And that way, again, we intend it as a way of gaining exposure and really being able to asynchronously evaluate and gain comfort, confidence, and competence, and being able to work and understand how the AI is actually working out. So again, we've made all the code publicly transparent. Anybody is welcome to go ahead and use it as they will, with the caveat that we did release it under a dual license. So AGPL 3.0, as well as for CV non-commercial use, and then the Compass CDA license for commercial use, modeling the licenses after NVIDIA and Meta's licenses for AI. Hopefully this has been helpful in just being able to kind of see what the menu for AI is out there, and really how inference on device, tooling on device that isn't after your privacy or your pocketbook is not only achievable, but it is well within our grasp. And with that, we will see you in the near future. Take care.